Hi, I am Rosanna Corona, and I will be going over Chapter 3 and Chapter 4 with you. First, let's begin with Chapter 3, Teaching Through Problem Solving. Okay, let's begin. Okay, first we want students to be able to make sense of a situation. We want them to learn to select solution paths, consider alternative strategies, and we have to monitor their progress. We will teach through problem solving, we will select worthwhile tasks, and we will facilitate the student engagement in those tasks. We will also encourage our students to ask. We want them to ask why, what would happen if, what is another way, how does this way compare to that way, will this always work? We need them to continue to ask questions so we know that they are engaged. Teaching for problem solving. It starts with learning the abstract concept and then moving to solving problems as a way to apply the learn. First, it would be explain, practice, and apply, but that approach has not been successful for many students in understanding mathematics concepts. So some teachers had to find other ways and select more helpful approaches for students. So the best way to help your students is to not help too much. Do not take away the struggle. Students need to get stuck on the problem so they could figure out, get their minds thinking about the alternative ways to solve the problem. We also need to teach about problem solving. Students need guidance on how to problem solve. Okay, there are 4-step problem solving process. Number 1, we need them to understand the problem. First, you must figure out what the problem is about and identify what questions or problems is being posed. Number 2, we devising a plan. We will think about how to solve the problem. Will you want them to write an equation? Will you want them to model the problem with a manipulative? What do we want them to do? How do we want them to solve the problem? Number 3, carrying out the plan. This step is the implementation of your selected plan. And number 4, looking back. It is the final step, okay, and it is the most important. When you determine whether your answer is from number 3, okay, as understood in step 1. Does your answer make sense? If not, just loop back to step 2 and select a different strategy to solve the problem, okay? Problem-solving strategies. There are many strategies to problem solve. So we will look for patterns, searching for patterns, including repetition, symbolic. It is an important entry point into thinking. Pattern seeking is an important habit of mind, and patterns and numbers and operations, and they will help students learn and master basic skills starting at the earliest levels and continuing into middle and high school. They will also visualize. Seeing is not only believing, it is also means for understanding, using manipulatives, acting it out, drawing a picture, things like that. Also, they will predict and check for reasonableness. This is sometimes just guess and check. Students are predicting more than they are guessing. This is not as easy as it sounds. It involves making a strategic attempt, reflecting and adjusting if necessary. Also, creating a list, table, or chart that helps writing an equation out. They need to see the symbols, the numbers, the equation, simplify or change the problem. The results of testing examples can provide insights into the structure of the task. So do not tell your students a strategy. They should learn how to pick and do it. So they have a different sense in their minds of how to do the problem. This is an example of a teacher and a student acting this classroom A problem. Teacher 1 here says, today we're going to practice problem solving. I'd like you to work on answering this question. You need to be sure to restate the question, explain your process, and check your work. What is the question asking us to do? Okay, and this one, the teacher 2, She is asking, please take out your problem-solving journal and begin work on this problem. Okay. The teacher places the problem on the overhead projector. The teacher circulates as students begin to work. After 7 minutes, the teacher asks a question. What do you notice about the pattern? And then students input, they start thinking. So there's different students. They start giving their input. One student here says, it looks like a table whose legs are getting longer and longer. Griffin here, the legs are getting longer by 1 tile. It's just an ongoing conversation and it keeps the students engaged. We need to teach through problem solving. Children are learning mathematics by doing mathematics. And by doing mathematics, they are learning mathematics. Okay, they will explore real context problems, situations, and models. They will form their explorations. From their explorations, they will learn mathematics. Teaching through problem solving positions students to engage in inquiry. We want them to question and keep thinking in their head. Students will ask questions, determine solution paths, use mathematical tools, communicate findings, make generalizations, reflect on the results. Features of worthwhile tasks. These are problems or tasks that have the potential to engage students in learning through inquiry, must be identified or created. Okay, they are at high levels of cognitive demand. They involve making connections, analyzing information, and drawing conclusions. We need to create a classroom experience for students where they can engage in learning through inquiry. So they find ways to identify and create different problem-solving tasks. Also, using context familiar for all students can be effective. We need to pull ideas from social studies, science, language arts, pop culture nowadays, sports, art, and we need to include that in these mathematics classrooms and problems that we are creating for them. For example here, I see 5 flowers in my garden. The first flower is red. The second flower is yellow. The third flower is red. If this pattern continues, what color is the 5th flower? We will not give them the strategy. Different students might solve this differently. So we will have them think about it. Next, evaluating and adapting tasks. We need to ensure that a task we are considering has the maximum potential to help our students learn mathematics. There are task evaluations. For example, the task potential, try and ask, what is problematic about the task? Is the mathematics interesting? What goals does the task address? What strategies my students use? Also, problem-solving strategies. Will the task elicit more than one problem-solving strategy? They need to look for patterns, create a list, table, and chart, write an equation. Task evaluation and selection guide. Also, the worthwhile features that I was explaining. They demand high cognitive levels, the multiple entry and exit points. They need to be relevant to the students nowadays. Also, assessments. We need assessments so we gain insights into the students' understanding. So we could do this through reflections and explanations. Also, developing concepts and procedures through tasks. The concepts. Students can expand and develop rich connections between mathematical ideas to develop new concepts. There are procedures. Students can invent their own strategies for doing procedures. There are multiple ways in how to solve these problems. Also, drill and practice. Practice refers to different tasks or experiences that are spread over numerous class periods, each addressing the same basic ideas. And drill refers to repetitive exercises designed to improve skills or procedures already acquired. Okay, orchestrating classroom disclosure. As students listen to other students' ideas, they come to see that varied approaches in how mathematics can be solved, and they can start seeing how it's done. Students are working, the teacher monitors, they could observe the strategies, the teacher will observe the strategies the students are using and asking questions. Questions are very important in learning about student thinking, challenging their conclusions, and extending the inquiry to help generalize patterns. Classroom disclosure includes oral and written language. Writing can be improved with the use of graphic organizers. Graphic organizers using the I think framework can help students be more aware of their mathematical thinking and better communicating that thinking to you, which provides you with better formative assessment data, such as individually think about the task. We want them to talk about the problem. How can it be solved? Identify a strategy to solve the problem. Notice how your strategy helped you solve the problem. Keep thinking about the problem. Does it make sense? Is there another way to solve it? Don't forget to take advantage of technology now, such as online blogging, wikis, Word, any text editing software. Here's another problem, hot chocolate math. How many different combinations of hot chocolate could you make? You must include one item from each category. So there's a flavor, a topping, a stir, a container. Now we will get into chapter 4, that is planning in the classroom based, planning in the problem-based classroom. A 3-phase lesson format, before, during, and after. Before, that is getting ready. Activate prior knowledge. Be sure the problem is understood and establish clear expectations. During, students work. That is when the students are working. Let go. Notice how the students' mathematical thinking processes provide appropriate support and provide worthwhile extensions. After, that is the classroom discussion. Promote a mathematical community of learners. Ask questions, listen actively without evaluation, and summarize the main ideas and identify future problems. Here, the students can go on their own and learn to record stats and measure different body parts, the length of their hair, shoulder to shoulder, hip to hip, knee to ankle, heel to toe. Process for preparing a lesson. Preparing a lesson is extremely important. The content and the task decisions, we need to determine the learning goals, consider our students' needs, select, design, or adapt a worthwhile task, and design lesson assessments. The lesson plan. We need to plan the before phase of the lesson, plan the during phase of the lesson, and plan the after phase of the lesson. Lastly, we need to reflect on the design. Reflect and refine. Learning centers. Students may work at different tasks at various classroom locations. The before phase, ensure the task is understood before you give it to them. Establish clear expectations. The during phase, the time where the students engage in a task, but they are stopping and rotating to new centers. After phase, different approaches. We may decide to focus on one particular center. We may begin with the center that was least challenging and progress to the one most challenging, or we may not discuss what was done at each center, but instead ask students to talk about what they have learned. Here are different activities that the students could do at the centers. They could create this butterfly, just do different activities. Differentiating instruction. A teacher's lesson plan should include strategies to support the range of different academic backgrounds found in the classrooms, either academically, culturally, and linguistically. We need to first consider the learning profile of each student. Second, consider what can be differentiated across the 3 critical elements: the content, what you want each student to know, the process, how you will engage them in thinking about the content, and product, what they will show, write, or tell to demonstrate what they have learned. Open questions. Many questions in the textbooks have only one answer and often only one way to get there. As a teacher, you can open the question and devise other questions that promote a more in-depth thought process. So you could go ahead and add to the textbooks problems, ask questions about it, different questions. The tiered lessons, this type of lesson includes a similar problem focus on the same mathematical goal, but adapted to meet the range of learners with different groups of students working in different tasks. The degree of the assistance, how structured the task is, the complexity of the task given, the complexity of the process. Parallel tasks. This type of lesson is similar to a tiered lesson. However, the focus now on choice. Students become motivated when they are given a choice and become more self-directed learners. This will be multiple choice tests and problems where they are given, choices between A, B, C, or D. There are flexible grouping, allowing students to collaborate on tasks, provide support and challenges, increasing their chance to communicate about mathematics and build understanding. We want them to communicate, to talk about it. Groups are important. You could select groups based on the student's academic abilities, such as language needs, social dynamics, and behavior. It is often effective to use mixed ability groups. We could strategically place struggling learners with more capable students who are likely to be more helpful. They might learn how to solve and use those techniques of these students who are not struggling as much. Also, we need to plan for family engagement. It is extremely important for the families to be engaged especially in mathematics. Many families or parents tend to disengage, but as a teacher, you need to make sure you plan for it. We need to communicate mathematics goals. Parents need opportunities to get information directly for teachers. You can have a mathematics program such as an after-school math meeting, once a month, or a family math night where you will introduce the component in the back-to-school night. We will discuss it in PTA meetings, or host a family math night and just have fun. Remember to have and give positive experiences doing mathematics. That could include the whole family participating in different math centers with their students and just having fun in these games. And that is it. The homework practices, we can't forget that. Solving math stories, try strategies. Right here, we could set up a note card for parents to help their child solve story problems. For example, read the problem out loud, paraphrase what the story is about, discuss math vocabulary, find and write questions, draw a picture of the problem, act out the problem, use household items to illustrate the problem, allow parents to know where to find resources to help their child. Resources include tutorials, video tutoring, connections to careers, and real-world applications. Multilingual glossaries are extremely important. We have multicultural students in our classrooms, and their parents should be able to help them no matter the language. And there are podcasts. Reading is an adventure that never ends. And that is my presentation. Thank you.